Hello, everyone. Welcome back. Today we are going to be talking about annuities, but borrowing. So, again, last time we talked about how we can make certain payments for a certain length of time and invest those at a certain rate. But in this case, we're going to be talking about how this works when we're borrowing money from a person. So, for example, let's say that we are borrowing $500,000 in order to buy a house, or maybe we're borrowing $50,000 to buy a car, and we're going to make an equal series of payments to slowly but surely get that loan paid off, right? So the formula we're going to use for this is the present value. So at the present moment, how much do we owe? R is for the regular payment. The small r is for the interest rate that we are being charged. And then N is going to be the number of payments left that we still must pay. So, not necessarily the number of years left, but the number of payments left. In practice, often both mortgages and car payments are paid monthly. And so each month we have to make a payment. So, we need to multiply the number of years by 12 in those situations. Okay, so let's do an example. Example one says, if Salmon can afford to make a car payment of $400 per month, what is the most expensive car he can buy if the loan is financed over 5 years at a rate of 7% compounded monthly? Okay, so let's first figure out our given, because we were given some things and we were given enough information to be able to solve the question. So let's write that down. Let's make sure we know that. Well, the first thing that's given is that Salmon can afford to make a car payment of $400 per month. So our regular payment is going to be set to $400 because we want to know the most expensive car he can buy, right? And so we want him to make the most expensive payment he can, right? So this is going to be basically top end of his budget. What's the most he can afford if he is willing to get this car payment? The loan is financed over 5 years. So N, number of payments left, because it's compounded monthly and he's going to pay $400 per month, is going to be 5 times 12, which is 60. So he will make 60 payments, right? He's going to make 12 payments every year, so one per month for 5 years. So in all, he's going to end up making 60 payments to this car. And the interest rate is 7%, but it's compounded monthly, right? Which makes sense because it's monthly payments. So we're going to divide the 0.07 by 12, and we're going to end up with 0.0058 as our rate. And then what are we looking for? We're looking for our present value, right? We're looking at how much would he owe if he were to go ahead and do this, right? What's the most expensive car that he could afford? Now, often too, when we get a car or a house, there's usually a down payment required. However, that's not indicated here. So I'm going to assume that he is financing his entire car, which I mean, not a very good idea. Better to pay cash for a car, but that's a discussion for another time. However, it doesn't look like he's even putting any money down towards this car. It looks like he would just get a car right now, today, and start making payments on it rather than pay a certain amount now and then have less that he owes later. Or better yet, get a car completely in cash and then not owe any monthly payments for the car payment. But yeah, that is a story for another time. The point I'm trying to make here is that there's no down payment that we would have to also add in to this equation here. Okay, so let's figure it out. Present value is equal to 400. 1 minus 1 plus r, so 1.0058 to the power of negative n, negative 60, over 0.0058. Okay, so now we're going to figure out what that is. First, I'm going to figure out 1.0058 to the power of negative 60. Okay, and then we're going to subtract 1 from that. Okay, we're going to multiply 400. And last but not least, I'm going to divide by 0.0058. So I'm basically plugging all this into my calculator. And my answer is $20,220.06. And so therefore, we know that the most expensive car that Salmon can afford is 20,220.06. So he can't actually afford this car in cash necessarily, but he can afford it in terms of he can afford to make the payments each month. If he makes this agreement, he will be able to follow through with it. If he makes an agreement at the same interest rate for 5 years for a different car that is more expensive than this, then he will not necessarily be able to make those payments. All right, so that's that one. Let's try two more, I think. This next one says if a family purchases a home for $400,000 at a rate of 5.7% compounded monthly over a period of 25 years, find the family's monthly payment. Okay, so this one, I'm surprised they didn't say that there was how much the down payment was, but I'm just going to assume that there is none because they didn't say that there was. But again, let's put in the given. Let's put in what's given. So we know that present value is $400,000. They owe $400,000 on their home they just bought. The interest rate is 5.7%, which is the same as 0.057. But again, we're compounding monthly and the payments are monthly as well. So this is over 12. And so that is going to be 0.00475. Okay. And then the period is over 25 years. So they're going to be making this payment every month for the next 25 years, which does sound like a long time, but actually many mortgages are anywhere from 20 to 30 years. So this is fairly typical. This is not necessarily a super long time considering what's the norm for home purchases. So N is going to be 25 times 12, right? Because they're going to make 12 payments per year for 25 years. So that's going to be a lot of payments they're going to end up making. So that's 300 total payments that they're going to be making. And then what we want to know is what is R, right? What is the family's monthly payment? So I'm actually going to go back and take a look at this equation, and I'm actually going to copy it down over there. Let's paste it over here. There we go. Because we're going to use this exact same equation again. So PV, 400,000 is equal to R, their regular payment, times 1 minus 1 plus R. So 1.00475 to the power of negative 300. Which should be a square bracket, I suppose. And then we have over 0.0475. So this time we're trying to solve for R, and so it's not going to be as easy as just solving for present value and we can just calculate it really fast and then get it done. I'm going to take a few different steps in order to do this. So my first step is I'm going to find out what R is being multiplied by. I'm going to multiply this up, and then I'm going to put in my calculator 1.00475 to the power of negative 300. So let's find out what that is. Okay, and then I'm going to subtract that. Okay, and then I get 0.7587, let's round up, R. So now all I need to do is say, okay, well that means R is equal to 400,000 times 0.00475 over 0.7587. Okay, so let's figure that out. So 400,000 times 0.00475 divided by 0.7587 is $2,504.28. Which honestly, given given the amount they owe and also given the high interest rate here, it is not that surprising that this is their monthly payment. So this makes some good sense. So then we can say, therefore, their monthly payment is $2,504.28. So that's the answer for that one. So the nice thing about these is that pretty much all these are pretty much the same, right? We have a certain interest rate, we have a certain present value, we have a certain regular payment, we have a certain number of payments we're going to make, and we just have to solve for whichever one of those we don't have. So that is the nice thing that I like about these questions, is that they're all pretty much the same, and the next one's no exception, although I will go through one more example like this. If a family purchases a home for $400,000 at a rate of 12% compounded monthly, over a period of 25 years, find the family's monthly payment. Now, this one is extremely similar though, because all the numbers are the same except for the 12% interest rate. So the interest rate is way, way higher. So I'm actually expecting, because of that, the payments to be way higher, even though the amount of time that it's going to take them to pay off this loan is the same, and the amount that they are borrowing is also the same. So let's go ahead and do that. So here, we know that R is something we don't know. We know that the present value is $400,000, right? That's how much the family owes on their home. We know that the interest rate is 0.12, but that's going to be over 12 because the interest rate of 12% that's compounded monthly, that's an annual interest rate. So we're going to divide that by 12. So that's 0.01, right? Okay, so 1% on a monthly basis. And then we have, what do we have? We have that the number of payments is still going to be 300 payments. So what I'm going to do, actually, since we already did the work over here, I'm just going to write the same thing down, but with the new numbers, because this is the exact same thing. And then what's this part? This is going to be 1. Yeah, this is going to be 1 minus 1.01 to the negative 300. And then let's solve and find out what that is. So 1.01 to the power of negative 300 is that minus 1. Okay, so that's going to be 0.949 over 400,000 times 0.1, 4,000. That's going to be $4,214.96, which is a lot more money than before. However, the consider this, that they're taking 25 years, which is a long time. Well, not a long time for a house, but just a long time in general to pay off this money. And also the interest rate more than doubled, right? It went from 5.7% up to 12%. So it's way, way higher. And so it makes sense that this monthly payment is going to be a lot higher, right? The interest rate that you're getting the a loan with makes a huge, huge difference. Now, generally, interest rates for homes are not going to be as high as 12%. Even 5.7% is a high interest rate for a home loan, at least in Ontario. So yes, but in this hypothetical situation where for some reason they agreed to a 12% interest rate and that was the best the bank could do for them, their monthly payment is $4,214.96. So yeah, so that is the end of this unit. Congratulations on finishing this unit. Don't forget to do the suggested practice problems, and we will see you next time. Bye.